Basically what it means is we're going to take a conic and it's going to be graphed at an angle. Of love to. I mean, not completely love to because it's sunny outside, but it's like the last day we're going to see sunshine for like a week. Okay, so we're taking a conic, and instead of being, as Jackson put it, like parallel to an axis, it's going to be graphed at an angle, okay? And we are going to today determine what angle our conic will be rotated at, and then we're going to rewrite the equation so that we can graph them tomorrow. We're not going to worry about graphing them today, we're just going to worry about rewriting the equation. Okay, now how do we know that we have a rotated conic? Okay, here is the standard form of a regular not standard form, excuse me, general form of a regular conic. Here is the general form of a rotated conic. What is additional? The XY term. Not a term we're used to seeing, so it should hopefully stick out, right? If we have an XY term, that really throws us off for completing the square, right? It really can't be associated with just the X's or just the Y's, because there's both in there. All right, so we are going to have to do some algebra to refigure out how to put this conic on a graph. Okay, the first thing we're going to work on is classifying a conic. Now, some of you, I think, looked this up the other day when you had your homework, because I saw some of you talking about the A's and the B's and the C's, or the A's and the C's, excuse me. But we went over the other day how to classify a conic based on their general form, right? If there's if there's only one squared term, it was a parabola. If the x squared and y squared are the same sign, then it's an ellipse. If there's an x squared and a y squared, but they're opposite signs, we have a hyperbola. All of that goes out the window if the xy term is present. Okay? Yes? I think it's an arrow. Oh. I took this image from somewhere, and to be honest, it has no relevance. It has no relevance. Okay, I see what you're saying. All right, so in order to be able to classify the conic, if it's being rotated, we're going to look at A, B, and C. Here are your three rules. Now, B squared minus 4AC. Does that look familiar? Yes. What is that from? That is underneath the radical of the quadratic formula. It's called the discriminant. If we look at the discriminant of a general form of a conic, it will tell us what kind of conic it is. So I'll give you a moment to go ahead and write that information down. Now, if the discriminant is negative, it says ellipse or circle. If it is a rotated conic, we are not going to be able to specify between the two. We won't know until we do the algebra. However, if we have a non-rotated conic, we can tell the difference between an ellipse and a circle, and I will expect that on your test next week. So we're going to do a couple, well, we'll do 3 examples just to get the practice. Okay. So our first example, we have 2x squared minus 3xy plus 2y squared minus 2x equals 0. As soon as we see that we have the xy term, we have to use the discriminant. Without the xy term, you can use your deductive reasoning skills to figure it out, okay? But we don't have that. Remember, A, B, C, x squared, xy, y squared. Those are your 3 coefficients. So when we're looking at the discriminant, we have to take b squared minus 4ac. So we have 9 minus 16. What kind of number is that? It's a negative number, which means we have an ellipse or a circle. I do expect you to write both of them. Like I said, we won't know specifically what it is until later. So I want ellipse or circle. Our second one, x squared minus 6y plus 9y squared minus 2y plus 1 equals 0. So to find the discriminant, we'll take b squared minus 4ac. I also, well, we're not going to have a calculator on the test, so don't practice with one. Okay. We have 36 minus 36. When it equals 0, that means our conic is a parabola. This third example, I will have you find the discriminant for without me. Yeah.
So for parabolas, when n equals 0, doesn't that just mean the coefficients are like the perfect squares ones? Because like, if you had x squared minus 6x plus 9, you couldn't factor that into that.
Well, but could it be 3? You mean all 3 coefficients have to be perfect squares?
No, I just like it factors to be a perfect square.
Like the 3 factors multiply to be a perfect square.
Completing the square.
It's saying that you can complete, like you don't need to complete the square for x squared minus 6xy. It is x minus 3 squared. That's when you apply a square.
Yeah. Like the 169. I'm going to have to think about that one. My goal is to just bring you.
Okay. what the discriminant is used for. Like if you can't find.
The discriminant
Well,
of
like
quadratic
in this quadratic.
is used to tell us how many zeros there are,
Yeah.
right?
Mhm. And when you get a 0 under the square root, that means you have 1 0, and that's the center, so that you.
I see what you're doing. However, we're not like factoring this. You know what I mean?
Right, but wouldn't it be the same principle anyways?
I see what you're saying. Okay, I'm seeing the connection.
Yeah.
Thank you. Okay.
I'm just trying to explain.
No, it's okay. It's good for you to practice that. All right, what do we have? Amanda, what is your discriminant?
A squared minus 64 minus 48.
64 minus 48. Okay, does it really matter what the exact value is?
No.
Okay, she didn't give me an exact value. That doesn't matter. As long as you can tell whether it's positive, negative, or 0, you can figure out what we have. So, here comes the fun. Yes.
How come we're able to classify the, like how much it's, like what it is by the discriminant? Like how come we're able to classify what it is?
How are we able to, like, why does this work?
Yeah, like why does it work?
Why does it work? After all the years of teaching patterns. Let me see here. I mean, I have to think about that, Connor.
Okay.
I'm not sure if I know how to answer that very well right now.
Yeah, okay.
Okay, so let me think about it and get back to you.
10-page long proof on the board.
Hopefully it doesn't resort to that. Hopefully.
Your life is gonna be fun.
Okay, if we are given a conic that is being rotated, in order for us to graph it, we are basically going to rewrite it in terms of x primes and y primes so that we no longer have an xy term. Basically what's going to happen is we are going to draw a new set of axes, the x prime and the y prime axes, and those are the ones that are being rotated. And then we'll have a new equation to graph on a new set of axes. Okay, and that's why you see like the x prime and y prime. So we are going to rotate counterclockwise at an angle. To figure out that angle, you're going to use one of these two. If you're more comfortable with tangent, write that one down. If you're more comfortable with cotangent, write that one down. with that angle, so we have this angle and we want it to look like this with x primes and y primes. So in order to be able to do that, we are going to rewrite our x and y term in terms of x prime and y prime, and we're going to do it like this. So write down what you need to, and then I'll talk about it more. I don't really want to talk while you write. I think I have an answer. So what's happening is we're determining, using these coefficients, what our angle of rotation is. Okay? We are then going to use these substitutions here to change all of the x's and y's in our equation. What's going to happen is we've chosen these x and y substitutions so that when we plug them in up here, the xy term will disappear. Did you notice that? From here to here, we lose that xy term. Now, all of these coefficients will be different, all right, which is why there's primes on them. But essentially, we're using these x and y substitutions so that the xy term will go away and we can graph our conic on a rotated axis. Okay? I'm going to warn you that these are pretty algebra intensive. Okay? You have 4 homework problems tonight, and we're going to get through most of one in class together. And then you have 3 problems. Okay? Only one of these will be on the test. Okay? So there's quite a bit to it. But since there's quite a bit to it, it is worth a lot of points, so it's not one that you can just skip. Okay? Now, we're going to take it step by step. We're going to go nice and slow. But you need to be paying attention, writing things down, asking questions. Now, Connor, the reason why the discriminant works is that we have a quadratic equation, right? Because we have like the x squares and the y squares. So what you can do is you can rearrange this to essentially solve for y. And then you can solve for y with the quadratic formula. All right, and I can kind of show you what that looks like in the book. I'm not going to write all of those numbers. So what happens, okay, if we think of an ellipse and a hyperbola, there's 2 pieces, right? Those 2 aren't functions. So like if we graph an ellipse, we could graph like the top of the ellipse and the bottom of the ellipse, all right? Where a parabola only has like 1 part. So kind of like Jackson was saying with the discriminant 0, basically we have y equals only 1 thing, and so it's giving us a parabola. Well, when the discriminant is positive versus negative, we have basically 2 equations in one, and so if it's positive, we have like a nice circle. Well, if it's negative, kind of inverts, and we have the hyperbola.
Yeah.
Or I said that backwards. I apologize, because this is positive. I don't know if that's the explanation you're looking
No,
for.
that makes pretty good sense.
Okay, excellent. So, other questions before we begin our adventure?
So we're just gonna do one example.
We're going to do one example together, and then we're going to work on a homework problem piece by piece by piece. Like, I'll say, do this, and then we'll check our answer, and then I'll say, do this, and then we'll check our answer. Okay? Okay. Your unit circle is going to be important. X stands for? Y stands for? At 30 degrees. What's our coordinate? At 60 degrees. What's our coordinate? Nice. 45 degrees.
Radical 2 over 2. Radical 2 over 2.
That was like the best participation all year. Very nice. Write it down.
Oh, that was simple.
And now she's gonna have to extend the page 5 times.
I will have to accept the page. Okay. My first question. What kind of contest? What is A? What is B? What is C? We have a positive number. So we have a hyperbola. You have to classify it before you move forward. All right. Now we need to figure out the angle of rotation. How many of you would prefer cotangent? How many of you prefer tangent? Perfect. So the tangent of 2 theta is B over A minus C. Okay. Well, B is 1, and A and C are 0.
So that means that you
Can't do
get
it.
a problem when we have to go to lunch.
No, not so much. What does it mean when we divide? The tangent can be undefined, can't it? Now, I will say that as we're doing these rotations, you want to pick the angle that comes first when we rotate clockwise. So when is the first place when we go clockwise from 0 that the tangent is undefined? Pi over 2. So that means 2 theta is pi over 2. So our angle of rotation is pi over 4. What? It was too nice. All of your angles that we use to rotate will be nice in a circle one. Because we don't have a calculator there. All right. Your next step is to figure out your substitutions for x and y. All right. So x. Oh, that's not the color. Your x, and this is something you're going to need to remember, is x prime cosine theta minus y prime sine theta. So for this example, our theta we figured out to be pi over 4. Hannah, you, what's the cosine of pi over 4?
Oh, wait, right?
There it is. The sine of pi over 4, again, what is it? So we are going to substitute in for x, radical 2 over 2x prime minus radical 2 over 2y prime. But that's not all. We need to replace y with x prime sine of theta plus y prime cosine theta. So do you see how sine and cosine switch places? And one's subtraction and one is addition?
Is it plus or is it
So y is plus. All right. Well, our angle is the same. The sine of theta and the cosine theta, those aren't going to change. So our y substitution is radical 2 over 2x prime plus radical 2 over 2y. All of this is just the setup. Okay? From here, which is what we're going to do when we get back from lunch, but from here, we're going to make the substitution and multiply everything out and combine like terms. We'll do it. It's going to be really a lot of fun. Now, we get to actually do the algebra. So our equation is x y minus 4 equals 0. Now, this one's a little bit more simple because there's only one term we have to substitute. But no matter how many x's there are, all of the x's will turn to radical 2 over 2x prime minus radical 2 over 2y prime. And all of the y's will become radical 2 over 2x prime plus radical 2 over 2y prime. Minus 4 equals 0. Okay. At this point, you need to multiply everything out, combine like terms, and what should happen is that your xy term should go away so that we can have an equation to graph on our x prime, y prime axes. Okay? So if your xy term does not disappear, you have done something incorrect somewhere in your algebra. Okay? So, here we go. This is what I noticed. I have a difference of squares. You guys are at the end of your honors pre-calculus class. You shouldn't have to FOIL this out so to get the AB terms to cancel. We know it's a difference of squares. We know it's going to be a squared minus b squared. So, what would a squared be? What is radical 2 over 2 times radical 2 over 2? 1/2. So we have 1/2 x squared minus 1/2 y squared minus 4 equals 0. Not always will x and y be a difference of squares. This is happening because our angle is pi over 4. It made it nice. But you'll need to be careful and really watch your algebra. Okay? Now that we have everything multiplied out, we come back here and we say, okay, we have a hyperbola. We need to get it into standard form. Do we need to do any completing the square? No. Since we have just x squared and just y squared, we don't have like an x prime or a y prime term. We don't need to complete the square. So what we can do is we can add that 4 to the other side. And a hyperbola in standard form needs to equal what? It needs to equal 1. So we can divide both sides by 4 to get x prime squared over 8 minus y prime squared over 8 equals 1. Dave. Right, so what we're going to do tomorrow, we're not going to do it today. Tomorrow, we would draw our xy axis, then we would draw our x prime y prime axis, and that's what we would do. No. No graphs today, graphing we'll do tomorrow. So this is where I'm going to ask you to stop.
Does it matter like if you put like the prime sign with it or?
Okay, so in your answer, you do need the primes because it's based off of a new set of axes. But if in your algebra you don't want to take the time to write the primes, you just write them in at the end, I'm not going to get too fussy about that. Okay, but this does need to be rewritten as x prime and y prime. Other questions? Like I said, you have 4, count them, 4 homework assignments tonight. Problems. Or do you have 5? 1, 2, 3, 4. You have 4. We are going to do number 19 together. It is not. It is the third one.
Oh, my classifying equations doesn't work.
We're going to do number 19. You want to do number 19. Trust me.
Oh, yeah, that's clear written there. Let's do it.
Okay, your first task is to determine the type of conic. Actually, I'm going to give you 2 tasks. Type of conic and the angle. Gabe, how did you set up the angle? Did you use tangent?
Yes.
So you have tangent of 2 theta equals?
Oh, 6 radical.
Okay, which reduces to what? Which reduces to radical 3. When is the tangent radical 3? So your angle is pi over 6. This is why I wanted to do number 19. Yes.
So the answer is always either going to be radical 3 or radical 2 over 2, because otherwise you get angles that aren't on the unit circle. Is that right?
Well, you could get like 0 or undefined, and you could get like a negative radical 3 or a negative radical 3 over 3. I mean, yes, you are right. There are only a few different angles that we're really going to be able to work with. Most of the time you will see these 2. Even more, pi over 4 is going to be pretty popular.
So when you do end up with a negative number, will it only be in the 4th quadrant?
Second quadrant.
Second.
Mm-hmm.
So you go counterclockwise?
Yes. So yeah, if you have like a negative radical 3, you would want to choose 2 pi over 3 as your angle. And I think that might happen in your homework. I cannot exactly remember. So now what I'd like you to do, what is our next step?
You have to substitute.
Okay, come up with the substitutions. Don't plug them in yet, but figure out what your x and y substitutions will be. Finn, what do you have for x?
Nothing.
For x? Okay. You have y. Okay. I'll come back to Finn for X. Will, what do you have for Y?
1/2 x sine plus 2y.
Finn, what do you have for X?
I have 1/2 x prime minus radical 3 to y.
I feel like those should not be the same. X is cosine minus sine. The cosine of pi over 6 would be
Minus 32. Negative cosine of pi over 6.
So would that change your answer?
Probably. I'm kind of lost.
Okay, Finn, do you see right here?
Yeah.
X is x prime cosine minus y prime sine. Okay. So if that's the case, then we would want
I did sine twice.
I see. So cosine x prime minus sine y prime. Does that look better? Okay. And then we have sine x prime plus cosine y prime. All right, here's where the fun begins. Plug them in and multiply everything out.
Oh my.
Yep.
Okay, these are brown fees on like for tomorrow's homework, like these problems.
Yes. You have to do these problems in order to be able to do your homework tomorrow.
I was gonna just like write it in and just walk through it.
Okay, my word of advice. Do your foiling first. Combine any like terms inside of your foiling, and then you can multiply the coefficient through. So focus on this quantity squared before you multiply the 13. Focus on this foiling before you multiply the 6 radical 3. Focus on this foiling before you multiply the 7.
That way,